Alrighty, well, I will begin with a word of prayer. Ahem. Heavenly Father, we thank you for this day. I thank you again for these students. Just ask that you'd be with us today, help us to glorify you in what we do, and I just pray that we would all just make the most of this time. And I also pray for the students as they're working on understanding the math in this class, that they would be able to address any misunderstandings they had on the quiz and just to correct things before the test next week, Lord. And I just thank you again for all your many blessings to us this day, Lord. In your name I pray. Amen. So make sure you have top hatted. Here's the code. So today, I'm going to start by telling you guys about lines. All right, so we're talking about lines here for a while. And then at the end of class, I will talk about the quiz. I have not finished grading it, unfortunately. I've graded I graded the first page in all the sections, and like the second page in some section, but I've only that far so far. All right, so let's talk about lines. So let's see here. Suppose you got a line, and it looks something like this, right? So it goes on, right? And if you had 2 points on the line, you could say more, right? Like suppose this point here is x1, y1, and this point over here is x2, y2, right? If we have those 2 points, we can make like a triangle. We can study the rise and the run. Right, like that triangle. We can talk about delta x, which is going to be x2 minus x1. We can talk about delta y, which is y2 minus y1. In the so this is sometimes called the run. Sometimes we call this the rise. So rise over run is what? You guys ever heard this before? The slope, m, is equal to the rise over the run, or delta y over delta x, which explicitly here is y2 minus y1 over x2 minus x1. Right, so this is slope. All right. What else can I tell you? If we knew this point right here, right, our standard notation for that is b. Right. So what are equations for the line that we know? I'll start out with slope, intercept. So this is y equals mx plus b. All right. So that's one way to write the equation for a line. Another way, which is super useful, is called point slope. That's what it sounds like. If you've got a point and you got a slope, you can write an equation for the line. And the equation is this: y is equal to y1 plus m times x minus x1. That equation gives you a line which has slope m and goes through the point x1 comma y1, point slope. There's another one which is called the 2-point formula for the line. So that looks like this: y equals to y1 plus, and what it is you just put in the formula for the slope over here, y2 minus y1 over x2 minus x1 times x minus x1. So there you go. That is the very greedy 2-point formula for the line. So if you're writing a computer program and you want an equation which automatically gives you a point, gives you a line through those 2 points, you can just shove your points into that, and there it is. Now that's, you probably need to safeguard it though, right? Because what happens with your points if x1 and x2 are equal? Yeah, if x1 and x2 are equal, the stuff breaks down, doesn't it? So that's why sometimes we need the standard form, as your book calls it. Standard, quote unquote, standard form has this, it's this ax plus by equals to c. That's the equation of a line in quote unquote standard form. So let me show you four cases that are worth thinking about. Everybody top-hatted? So the four, I think everybody can see if I write here, right? So there's not going to be a lot of information on these pictures. It's really just for the sake of discussion. So draw 4 pictures. Four pictures here. Excuse me. So these are the 4 cases I think about sometimes. You could have a line like this. You could have a line like that. You could have a line like this. Or you could have a line like this. So these 4 cases I want to talk about just a little bit. So the first case, or the most leftmost case here, we have positive slope, right? M positive. The second one, we have negative slope. The third one, we have slope 0. And the fourth one, we can either say m is undefined, or if you like, you could say m is infinity. So the last 2 cases, these are really special lines. They have their own names, right? This is the so-called horizontal line, right? Horizontal. And this guy is a vertical line. Vertical lines are kind of oddballs. They do not fit, like you cannot use slope-intercept, you cannot use point slope, and you cannot use the 2-point formula for a line with respect to a vertical line. All of these fail because the slope-intercept, the point slope, and the 2-point formula for the line, essentially what those are doing is defining y as a function of x. The vertical line fails the vertical line test as bad as you possibly can. Right? Like how many points intersect the vertical line if you test it with itself? Every single point. So it's pretty bad. Anyway, long story short, vertical line is not the graph of a function, but it is the graph of an equation. If this is a, what's the equation of this? It's just x equals to a, right? All right. Oh, and then finally, definition. If y is, let's say y1 is equal to m1 x plus b1, and y2 is equal to m2x plus b2, all right, where m1 and m2 are not equal to 0, then number 1, the lines are parallel. We can use a symbol, all right? Provided m1 equals to m2. And number 2, if m1 is equal to minus 1 over m2, or m2 is equal to minus 1 over m1, those are the same equation, right? If either one of these is true, the other is, right? You can either say the second is the negative reciprocal of the first, or you could say the first is the negative reciprocal of the second. Same equation, right? Same equation. Then the lines are perpendicular. And my symbol for that is this. Right? So this right here, what I put on this board, this is our toolkit. This is what we have to work with. So pretty much all of the examples flow from applying these ideas. I would encourage you to have pretty much most of these ideas on your formula sheet. Yeah? I think that would be wise. So let's start out with like a really easy example. It's almost too easy. Y equals to, 3x minus 7. What's the slope? What's the y-intercept? Yeah, slope equals 3. Y-intercept is minus 7. All right, example 2. Suppose you got y is equal to, 17 minus 3 times x plus 1. Tell me the slope and tell me a point on the line. I'll do the easy part. Slope is what? M equals minus 3. And the point is, apparently, minus 1 comma 17. If you understand point slope, yeah? If you understand the point slope, all you have to do is look at it and you can see the point. Let me walk you through it. So if you don't understand why point slope works as it does, think through it. If you got an x plus 1 here, right? That means if you put x equal to minus 1, this part is 0. So I put a minus 1 there for the x. What happens for the y? That's 0, which leaves you that. It's not hard, it just might be unfamiliar to you. Let's do another. Y equals to 300 plus 20 times x minus 7. Again, what is the slope and what's a point on this line? What's that? Slope is 20. And what's the point? So, so 300 is the y part, right? So what was the x part? 7. Oh, 7. Okay. Sorry, my ears are playing tricks on me. Yep. So that has that slope and it has that point.
So we don't try to find the y-intercept for like.
Ah, yes. The y-intercept has nothing to do with anything here, does it?
Nice.
So this is the thing, is you guys have been taught y equals mx plus b so much that it's almost impossible for some people to think about a line without writing down y equals mx plus b. Your teachers have so emphasized y equals mx plus b, it has taken too important a role in many students' minds. And I had to break free of that myself as well. It finally dawned on me at one point that the point slope formula actually is more often than not what I need. Oftentimes in calculus, we know the slope of the slope of the tangent line, and we know the point it's going to go through. So if you know the slope and you know the point slope is what you want. Very rarely in an applied problem, calculus-based problem, do you know the y-intercept. Why do we teach y-intercept so much? Well, the formula is easier to think about, It's the y-intercept, so that's kind of a good thing to hang your hat on for graphing. I understand the preeminence of this formula in like pre-college algebra math, and even college algebra, but all right. Let's move on here. I will get off my soapbox. This is here, example 4. So let's suppose we've got 3x minus 7y equals to 20. Let's ask a variety of questions here. Question A, let's say find point slope. Not point slope, I'm an idiot. Slope intercept. So after all that bad mouthing slope intercept, let's get back to it. So find the slope intercept form. B, find slope. C, find y intercept. D, find x-intercept. E, find parallel line through, we'll fill in a gap there, F, find perpendicular line through, and I'm going to let you guys pick the points. I should have added a graph in here somewhere, right? If you don't mind, I'm going to make it E, F, G. What comes after F? Oh yeah, G. G, graph it. G for graphing, just like I planned. All right, so part A, how do you do it? Isolate y. Right, so solve 3x minus 7y equals 20 for y. So I'll subtract 3x to the other side. Everyone top-hatted? So I got 24 or 29. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19. Okay, everyone who's here has. Many times, I look at the number that have top-hatted, and then I count the students in the room, and like there's always like a couple. This is rare. I mean, I still have like a couple people in Math 115 who haven't gotten top hat to work for reasons I don't understand. Nor do I want to understand, right? Like, I like math. I don't like solving top hat problems. So anyway, y equals what? Y equals divide by -7, right? Thanks. So we got minus 20 over 7 plus 3/7 x. So there you have it. That is the slope-intercept form of the line. And from that, we can easily answer parts B and C, right? So m equals to 3/7. C, the y-intercept B is minus 20 over 7, right? Now we're to x-intercept. How do you find the x-intercept? To find x-intercept, we set y equals to 0, right? Because if you think about it, where it intersects the x-axis, that's where y is equal to 0. So you've got choices, right? You got choices. You can either put a 0 back in this equation. I don't recommend it. Or what's easier and lazier is to go back to your original equation and put 0 up in there. See, because we got 3x. Yeah, minus, I'm going to write this out just to make clear. Some people understand what I did. I'm plugging 0 in for y, right? And so yeah, 3x equals to 20. Divide by 3. We've got x is equal to 20 over 3. So the x-intercept is that, or better yet, the x-intercept is at 20 over 3, comma 0, right? So I said that the y-intercept B is minus 27th, right? But where is the y-intercept? It's at where? It's actually at the point 0, comma, minus 20 over 7, right? So sometimes you can refer to the y-intercept by the B notation, right? But it's often wise to refer to it as a point because that's what's on the graph, right? Just like this point is on the graph, you know? Incidentally, if you find the x-intercept and the y-intercept, it's easy to make the graph. Because if you know the x-intercept and y-intercept, then you got 2 points. So you can make the graph. If we could skip ahead to F, let's do it. Let's skip ahead to F. Oh, my bad. Yeah. Sorry. Gee. Forgive me. All right, so let's see here. Decimals are sometimes nice. 20 over 3 is what, like 18 and 2/3? So, wait a minute, no, I'm an idiot. 6 and 2/3. Ooh. So, yeah. It's the devil's point. All right, 6.66 here. Repeating. I guess we could just make do with 1 there. Now it's less evil. You happy? All right. And then 20 over 7, that's like 14 and 6/7. That's like, oh, it's going to be 14. That's like 2 point, what's that, 2.85? Minus 2.85. So it's like not quite half of that. It's somewhere here-ish. So crudely speaking, it's these 2 points, right? And then you just need like a ruler to connect them, right?
On the test, would you care that we use for fractions, or do you want decimals?
Fractions are good. Fractions are your friend. I'm not sure this is going to work, but I'm going to try. Submit. Nope, stop it. Ha! There. That's the straightest line I've managed today so far. So I hope you're happy. I knew there had to be use for this. See, I'm thinking, like what I want to do is I want to set it up and like draw a nice handlebar mustache on it, like right, so I could start the video like behind the thing with like a nice like mustache, maybe a hat, something. I don't know. I'm gonna get to it. Okay, so there's the graph. All right. Now, to find a parallel line or a perpendicular line, there are infinitely many parallel lines and perpendicular lines to a given line, right? So to find a specific one, we need like some additional information. So you guys tell me, what point? You pick a point, any point. What do you want? I will accept almost any point here. Give me a point. 1. That's the one I will reject. I got that in the last class. I allowed it last class, but I decided I had enough of it today. 2. I will also reject that. I want some diversity in my
1, 2?
1, 2 I'll take. Otherwise, it's hard to see the contrast of the x and the y, you know? And let's make the other one like, you know, -3, -8, okay? I probably will regret that. Oh, well, it's too late. So, all right, what are the equations then? E, we want slope, m equal to 3/7, and point, we just made it up, 1, 2. The equation is y equals to 2 plus 3/7 x minus 1. There you go. That's the equation of the parallel line.
Why is slope m? Like, what does the m stand for?
Slope.
Yeah, but like when was s?
Why not s? They must have already used s for something else. Whoever did this the first time. Maybe they were hungry. I don't know. Like, That's a good question. Why is it m? Why is it b? Why is b the y-intercept? What's that? It can't be y. I mean, this is good. I mean, you have to rule out x and y. That's the starting point. I like that. I mean, sometimes you can give an answer to these kinds of silly questions, right? Like, This is our notation for integers, right? This is 0, plus or minus 1, plus or minus 2, things like that, yeah? Like, why do we use a z for integers?
Why?
What? Well, because Germany used to be the center for much of the higher mathematics in the world before World War II, before we, got all of their leading scientists and stuff here. And so in German, integer is like Zahlen is for number. So it's German in its origin. But not all of these are like this. Like this one, these are real numbers. So it's like, it's just it's an R, it's a funny looking R, or natural numbers. See, these are English based. So it's kind of funny. I don't know, the origin of words. Anyway, that's the equation. There it is. What does the graph look like of that parallel line? 1, 2, right? Where's 1, 2 here? Roughly speaking, here-ish, right? I mean, I haven't really checked for scale. This was 6, right? It should be like a third of the way there. Maybe it's kind of, sort of, I don't know. Whatever. And so I should have, well, yeah, and that's not quite parallel either, is it? But you get the idea. Something like that is that one. And how about f? We want slope m equal to -1 over 3/7, right? Because definition, perpendicular line has the negative reciprocal of the slope of the line for which you're making it perpendicular to. That's a lot to say. Very good. That was the next thing I was going to write, so thank you. Much appreciated. And then our point, we picked our point. I picked it -3, -8. And so point slope, here it is, y equals 2, -8 is the y, -7/3. X minus a -3 is x plus 3. And so there you go, that's the equation of the perpendicular line. Like that. What if we, and we could try to graph that, right? It's at -8, -3, -3, let's see here. So it's like here-ish, and then down 8. I don't know, it's something like down here-ish. That is roughly speaking -3, -8. And so the perpendicular line will be something like this. Right, and if I did it right, it would be perpendicular to both of these lines, which are parallel, right? And you could set up a whole grid, right? Like a tilted graph paper if you wanted to keep going with this. Particularly easy question, I think I asked this on your quiz, was to find the line which is parallel or perpendicular through the origin. That one's a little bit easier. Why? Because you could, like if I add a part GH, parallel line through origin, what can I do then? If the line goes through the origin, what's the y-intercept? B is equal to 0, right? So we can fall back on the mx plus b formula here. It's really easy to use that in this case. So the parallel line through the origin would just be like y equals to, 3/7 x. The perpendicular one through the origin would be minus, what was it? 7/3 x, right? Trying to make sure I don't flip them. Did I just flip it? Okay, we're fine. It's been a long day. I'm wary of my formulas. And so, of course, those two lines we could add to our graph. If we were so foolish, that would be like this one. That was supposed to be a line. And this one, I should have stopped while I was ahead. So that's pretty much all I've got to tell you guys about lines, right? There is another, there's another formula for lines called the intercept form. Like there's a formula you can write that it makes it obvious if it's in that form what the x-intercept and the y-intercept are both at once. But there's about a 60% chance I get like really confused and stuck in the derivation of that formula. So let's not do it. And also, I think we can solve all the problems that we need with what I've showed you already. So I think this should suffice for this course, yeah. But lines are important, right? Lines are the foundation, one of the foundational pieces of the story of math. I mean, since Euclid, we've talked about lines. Probably before then, right? Can you build a pyramid without knowing what a line is? You know, yeah, I mean, lines are foundational to geometry, aren't they? All right, so let's talk about your quiz. And I'm going to try to address a couple points today just to get us started. All of Monday is a review. Monday is completely devoted to, I will be in sackcloth and ashes. There will be weeping, there will be wailing. I will be hitting my head against the board because I will have completed the task of grading. And the full weight of the sins of all 4 sections of college algebra will be upon me. And then I will have no choice but to behave like that. No, I'm just kidding. I mean, we will figure out what you guys did wrong and we'll try to fix it before the test Wednesday. Now, if you don't want to wait till Monday, and I would advise that you don't wait till Monday to do all that, right? There are solutions posted for both versions of the quiz, right? There's quiz version A, quiz version B. I've also posted in the learning section of the modules blank copies of quiz A and quiz B. So if you took quiz A, you could try quiz B once you've studied a little bit more and see how you do, right? And that would give you some sense of if you improved. And the solution for both quiz A and quiz B are posted. There are some errors in the solution at the moment I haven't fixed yet. So maybe you'll find those. Would you like me to tell you what they are? So like there's one where I used the cube formula, a cubed plus b cubed, and I inadvertently put a 4 where I should have put a 2. So there's that. What? Okay, so and there's another place I put a minus where I should have put a plus in the completing the square solution for one of the versions. Anyway, I'm going to try to fix those and repost the solutions here before I leave today. All right? So if you find what you think is a mistake in my solution, let me know. I might have made a mistake. I am human. I do make mistakes. So how do they say? If you see something, say something. Yes? All right. So let us talk then about the specific problems on the quiz. Right? So let me address some pretty common mistakes. So like I said, I've graded the first page, so I'm mostly talking about page 1. Here's the first one. A lot of you said x squared minus 7, or something like this, could not be factored. Yeah? But in fact it can, because this is x squared minus the square root of 7 squared, right? The instructions at the top of problem 1, what were they? They were factor the polynomials below completely over R, right? Instructions. Factor polynomials completely over R. What that means is you can use real numbers to factor, not complex numbers, right? Just real numbers. So the square root of 7 is a real number, you're allowed to use it. And in so doing, this gives us x minus square root of 7, x plus square root of 7. There you go. That's the answer. Question?
Yeah, why does it work like that?
Why what?
Why does it work like that?
Oh, well, I mean, this is the difference of squares. formula. So like day one of the first formulas like I told you guys to put on your sheet is this one. Anytime we have a squared minus b squared, we can always rewrite that as like, a minus b times a plus b. You could put the plus or the minus first, it doesn't really matter. But so we're just thinking of x as being a and b as being the square root of 7.
So b doesn't have to necessarily actually.
B does not have to be it doesn't have to be a whole number, no. Sure. Okay, so that's one problem. Now, in the first section that I talked about this, there's a fellow, he's like, but I had x is plus or minus square root of 7. That would be okay, right? So what do you guys think? X equals to plus or minus the square root of 7 for this problem. What do you guys think about that? What is this? I mean, what the instruction says factor polynomials. Factor the polynomial, right? He solved it. Right. So this is a different question entirely. This is the solution, if you're solving x squared minus 7 equals to 0, right? You get x squared is equal to 7. You can use the square root property, plus or minus square root of 7, right? Alternatively, of course, you could set this equal to 0, and then that will tell you x is equal to square root of 7, or minus square root of 7, right? But the point is, what I just wrote in blue was not in the problem. The problem is to factor the polynomial, not to solve the equation. Now, if you have done this, do not feel bad. You have many, many brethren. You are legion in this class. About half of you are laboring under this unfortunate confluence of ideas. It's understandable you have confused the idea of factoring and the idea of solving, right? This is very common. This is one of the fundamental confusions of college algebra. Maybe it is the fundamental confusion of college algebra. All right, so you need to separate these ideas in your mind. Factoring is involving expressions. The answer is an expression. See, an expression is not an equation, it's not a number, it is some formula. We're taking a formula and we're massaging it with algebraic techniques to get another formula. This is factoring, all right? Solution, on the other hand, solving an equation, you're looking for a number, a set of numbers, you can form the solution set with all the numbers that work. Different problem. Are they related? Sure, right? If I can factor it, I can solve it, right?
And you can graph it.
And then you can, we're good there. Not yet, but after test 1. But in fact, you can go both ways. It's also true. If you could solve it, you could factor it, right? That's true. There's a factor theorem. We'll talk more about it as we go on. If you can solve it, you can also factor it. It goes both ways. But you have to actually go that way and factor it, because the question which is asked is to factor it, not to solve it. So that's why I will take off a lot of points if you solve it instead of factoring it. Now in the quiz, I give you like half credit for doing it correctly. Like if you solved it correctly, right, but you didn't factor it, I still give you half credit. But I would probably take off more on the test. This is something that needs to be fixed. So please, I'm begging you, pay attention to the difference between factoring versus solving. This is an easy thing to fix if you just open your eyes to it, right? If you're solving it correctly, you probably almost already have all the tools you need to factor it correctly. You just need to factor it. Yeah. All right, enough about that. Another one people had some trouble with was x to the 4th minus 81. Now, a lot of you started out pretty well. You did this. A lot of people did this, and I was happy. Like, yay, woohoo. This is a good start. That's true. We can do this. And then you stop there. And I was like, aw. Aw. But there's more. There's more, because x squared minus 9 factors to x minus 3 times x plus 3. And then at that point, you're done, because all of these are prime. You can't factor any of these further. That's the end of the road. There, it's completely factored over R. So again, I give you half credit if you did the first line but not the second, because that's a step on the way, but it's not the way. I mean, it's not all the way. Any questions? All right. Another one people had some trouble with, and this one here, I'm not surprised you guys got this wrong. In fact, like I didn't talk much about this at all in class. I really didn't touch on this much in class. It was in your homework, but it's easy enough to forget about this idea. And that's part of the reason I put it on the quiz, is just to remind you. I think maybe 5 to 10% of the class got this one right. So if you got this one right, you've done very well. But x cubed plus 3x squared plus x plus 3. How do you factor this thing? So let me tell you one thing some of you did, which was wrong. And I saw a few students do this. They factored an x out of all of this. But yeah, well, that is what we're going to do. But so you can't factor an x out of the totality of the expression because there's no x over here, right? So, but we can factor an x squared out of the first two, like so. And that will leave us with x plus 3, right? And then if you use your imagination, you've got another x plus 3. So these two terms become these two terms, right? And then, well, this is plus 1 times x plus 3. I'm just writing the 1 there for emphasis, because then you can see that there's a common x plus 3 factor, right? Which then by the distributive property, we can rewrite this as x squared plus 1. This is called factoring by grouping, right? So I haven't done a lot of this in class. It's not something I've emphasized. So so if you got this wrong, don't feel too bad. But now I've reminded you, and this is something you'll be looking out for, right? Especially if it's a cubic problem, like problems that are third order. This is one of like the only tools we have to work with. The other tools we have is what the, like this one, x cubed plus 8 is what? X cubed plus 2 cubed. And remember the formula we had? A cubed plus b cubed is a plus b, a squared minus ab plus b squared. So with that, you can factor this to, x plus 2, x squared minus 2x plus 4. So this is where I put a 4 there in my solution. That's what I was talking about, guys. I need to fix that. And the current solution, which is posted, I have a 4 here because I'm a dummy. Yep.
Can you go through question 6 on the quiz?
Yeah, sure. I can. Number 6. Now, I hope I have the right. I got version B. I'm with me. I'm not sure. Maybe there's a 50-50 chance I got the right one. Yeah.
What formula is that one called?
This one? Oh, you could name it whatever you wanted. I don't really. I guess it's the sum of cubes formula. I don't really know. It's not. It doesn't have like a. I don't have a good answer. That's a hard question for me. I don't know. I think I just call it the sum of cubes formula. This one this one up here, difference of squares, right? Difference of squares, sum of cubes. I once had a class with a professor. We had this homework. It was a class called topology, and he gave us this problem. He said, prove this is a topology. It was this weird example. And then his part B was name the topology. And so I did it. I'm looking at its properties. I'm like looking at my book, trying to figure out what in abstract math, we make things look weird, and then it's like something in disguise. So you're like, what is this really? Like, what's the name of this topology? Like, which one of the standard examples is this, right? And we thought about it and thought about it and thought about it. Finally gave up, turned in our homework, and then we asked the professor next time, we're like, what's the name of that topology? And then Dr. Latta said, oh no, I was telling you to name the topology. Like, name it. It's like, you jerk. That was his sense of, he executed that joke perfectly in that homework, and he wasted an hour of my time on it. So well done, Dr. Latta. All right, anyway, was it this one?
Yeah.
Which one?
Well, it was.
Or all of the above?
Just A.
A, okay. 6x over x minus 6 equals to 9 plus 7x squared over x minus 6. Oh, I remember what else I was going to tell you. A lot of you are using the quadratic formula and you're not using it well. Like you're spinning your wheels. I could see you're like not comfortable with it. Many people need to practice more on like how to solve a quadratic equation, basically. All right, so this one here, multiply by x minus 6. We get 6x is 9 times x minus 6 plus 7x squared, right? That's you probably did that, right? Now, here's where it gets interesting. So then this is 7x squared. So I have a 9x on this side, I've got a 6 on this side. So if I subtract 6x, I get plus 3x total here, minus 54 equals to 0. So clean it up, rearrange it, put it in standard form, that's what it looks like. All right. So I got 9x from here, and then I have to subtract that to the other side. So 9 minus 6 is 3. All right, now this one's a little bit messy. Now this one stumped me when I tried to do it. Like I was like, I tried to factor. I couldn't see it. I just couldn't see it. And then when I completed the square, I found the solution. And then I was like, oh, this could be factored. Because once I completed the square, the numbers were nice. And then I was like, oh, duh. So there are nice numbers here. What are they? 54 is what? 1 times 54. I'll do. That's dumb, right? 2 times 27. What else? 6 times. 3 times 18. Yeah, that 3 times 18 is that's where the magic is. See, because that 3 times 7 is 21, and 21 less 18 is 3. So that was it. That was, yeah. So what you want is a minus 3 and a plus 18, I think. Oh, good grief! That's so it's maximally wrong almost. Let's hear. So let's try this. Minus 18 plus 3. How about that? That's probably better, yeah? So now I've got a minus 18, a plus 21, which gives us a 3. So there you go. And then, of course, once you've done that, that gives you x is equal to 18 over 7, or x equals to minus 3. All right. Now, you could have done the quadratic formula here, but you need to, if you're going to use the quadratic formula, I do insist that you simplify. I don't want to mess with the square root I have to like unravel. If you use this quadratic formula, it's on you to simplify the arithmetic. Let me say that to be clear here. So a problem like this, if you use the quadratic formula, and you could, what would it look like? You know, minus 3 plus or minus the square root of 9, 3 squared, yeah? Minus 4 times a, which is 7, times c, which is minus 54, divided by, well, 2 times 7. So what you got there is minus 3 plus or minus the square root of a big number, right, over 14. So it's a big number. And it turns out that that's minus 3 plus or minus 42 over 14. And so that either gives you, 30, is that right? I may be wrong. Maybe that was 39. It was 39. So that either gives you 36 over 14. I was right?